No video. Okay. Statement of no effect, no fair coin. It always, I'm going to underline always, has an equal sign. Okay. And it's always about the parameter. Okay. All right. So now let's talk about parameters. Give you some examples. What are the letters that I would use for a parameter? P hat is not a parameter. P is. What would be another parameter? Mu would be sigma. Did you say n? I'm not going to do a hypothesis test about my n, but I guess I could. What else somebody said? What? S is a statistic. No. X, no. R, I could do one about R. I don't know if we will. I always like to use the letter D because we'll talk about that one later. There might be some other ones. M probably. Okay, so letters that I should not use. I'm not going to write them on the board because you'll probably write them down. Do not use X bar. Do not use P hat. Do not use S. Those are statistics, right? Those come from a sample. It's always about the parameter, which I guess I can also put population. Okay? All right, now let's talk a little bit about the alternative hypothesis. Alternative hypothesis. Okay? The alternative hypothesis is either written as H1 or H sub A. I use both interchangeably. There's no real difference. But it is a statement we are trying to find evidence for. Okay? H sub 1 or H sub A. Okay? All right. Now we've got three types. Okay? So one, I have a two-tailed test. Okay? So if my null hypothesis is some sort of a parameter equal to some sort of a number, my alternative hypothesis would be the parameter does not equal the number. Okay? The two-tailed test. That's right. Now, another thing that I could do is I could do a left-tailed test. And that would be, the null hypothesis would be some sort of parameter equals some sort of a number. The alternative would be the parameter is less than whatever the number is. Okay? So the idea, and maybe I should draw a picture here, okay? We're trying to find out if something's in the left tail. With this case, we might not know if it's greater than or less than, so we'll do both tails. Okay? And then the third option is what we call a right tail test. So your null hypothesis is the parameter equals some sort of a number. The alternative hypothesis is the parameter is greater than the number. So if I'm drawing my picture, I'm looking at the right tail. That's usually going to be a normal distribution or a t-distribution that doesn't happen. Okay? All right. So let's do a few examples here. Okay. All right. And it's way out of focus. I don't know how I can focus that. There we go. A little better. Still out of focus. All right. Let's say that a pharmaceutical company develops a new antibiotic for children. Other similar antibiotics have side effects in 2% of children. The FDA wants to know if the new antibiotic has side effects in more than 2%. Find the null and the alternative hypothesis. Okay? So, I'm going to pick on Christopher. Okay? So let's review our statements here, especially this one. What does that say? Always has an equal sign. So I'm going to start off with my equals for my null. What do you think the null hypothesis? Something equals something. What percent? 2%. So I'm going to write 0.02. And then you gave me a bunch of words, but I want a letter. You said P? Why did you pick P? Because this is the first one. Okay. Is there a better reason why P would be the correct answer? Let's use the word proportion. Okay. We're looking for a proportion. Okay. Not a probability, but a proportion. Okay. Very good. Now, what do you think the alternative hypothesis is? What does the FDA want to know? 2%. More than 2%, right? So is this a what kind of a test? It's going to be a right tail test. So P greater than 0.02. Does that make sense? Okay, so your homework is going to be just figuring out the null and the alternative. We're going to give you a bunch of different scenarios, find the null and the alternative. No math. Okay, we'll save that for tomorrow. Okay? All right, but this is the foundation for the next 4 chapters. Yes?
And we're always going to use P most of the time?
No. We're not always going to use P. Okay? That's the other part. Okay? But we'll use some of these other parameters here. I just erased that, but hopefully you guys can remember it. Okay? Let's do another example here. Let's say that the blue book shows 3-year-old Chevy Corvette is worth $37,500. Grant wants to know if the price is different in Miami. Find the null and the alternative hypothesis. Okay, Spencer, it must be your turn. What does the null always contain? An equals, so I'm going to put an equals there.
so it's gonna equal 37,500.
Something is going to equal $37,500. Okay, what is the something?
Mu.
Mu, why did you pick mu?
Because it's an average.
He used the A word, but he meant.
I mean.
Okay, he picked mu, and he knows he's not supposed to pick X bar, because X bar is a statistic, right? Okay? Very good. All right, now, what should the alternative be?
It's not equal.
Not equal to, why not equal to?
Because it's different.
Yeah, he just wants to know if it's different. It doesn't tell you whether it's higher or lower. He doesn't have any idea, right? And so what's not equal to?
Mu is not equal to 37,500.
U is not equal to 37,500. So what kind of a test is this? A two-tailed test. Now, just say that. We're going to do, tell me more about what that means tomorrow. But I just want you to recognize it is a two-tailed test. Okay? All right, one more. Let's do the standard deviation of a 64-ounce bottle of detergent is known to be 0.23 ounces. Company purchases a new machine and hopes for less variation. Find the null and the alternative hypothesis. So Kyle, it must be your turn. What do you think?
It's gonna be sigma
Sigma.
equals 64.
I think you meant 0.23 ounces,
Yeah.
right? Okay. Why did you pick sigma?
It's a standard deviation.
Because you're asking about standard deviation. Okay. The alternative should be
Sigma is less than the 64. Or is it going to
you
be
keep going for the 64. No, that's just a distractor, but it's distracting you well.
0.23?
0.23. Whatever they have number here, you use the same number there. Okay. But this one is going to be a left-tailed test because we want to know if it's less than. Okay. This is going to be a left-tailed test, right? All right. Okay, so let's talk about the kind of mistakes that can be made. Okay?
I have a question.
Yes.
How does this, with the left tail and right tail, would we use this in combination with like a t-test, like
Yes,
finding the
that's
area?
exactly what, yeah, we're not going to get into that, but that's where we're going.
Yeah.
Okay, we'll go into that tomorrow. Okay? All right, so there's two types of mistakes that you can make. There's two. Okay, so let's talk about reality. The null is true, or the alternative is true. And let's talk about your conclusion. Do not reject and reject. Okay, let's go back to the simple coin problem for a minute. Okay. So let's say that we flipped a coin 10 times, it came up 5 heads. You'd probably say 5 out of 10 is that there would be pretty good evidence the null hypothesis would be true, correct? Okay. So you'd say, I'm not going to reject the null. I think the null is true, and you would make a correct conclusion. Okay. Now let's say that flipped a coin 10 times, it came up with 0 heads. Do you think that would be pretty strong evidence that the alternative hypothesis would be true? Yeah, okay, that would be strong evidence. And maybe it's a two-sided coin or something, right? So you'd say the alternative is true, you would reject the null, and so therefore that would also be a correct conclusion. Okay? Now the question is, if a coin comes up with 6 heads, is that strong evidence that I'm cheating? No. 7 heads? No. 8 heads?
Evidence is a loaded word.
Yeah. Well, what do you think? 8 heads?
No.
Maybe, right?
A billion out of a
9
billion
heads.
still isn't evidence.
9 heads? No. You're saying no?
I'll say no until you run out of numbers.
10 heads?
No.
That's not evidence?
It's still on the probability table. It's not evidence.
It's pretty strong evidence.
It's not evidence. You're misusing evidence.
Okay. So if we were betting, and me and you, Adam, we're betting.
Betting's
I
different.
got 10 heads. I got 10 heads. Do you think I'm cheating?
I would.
Oh, you said there was evidence.
That's not evidence.
So there's
I would
evidence.
think that. No.
Okay.
What I think and evidence aren't the same thing.
Okay, don't argue with me. Okay, so that would be pretty strong evidence, right? Now, could a coin come up 10 times in a row, tails, and not be cheating? Yes. Okay, you could make a mistake. That's what I'm talking about. It's the possible mistake that you can make. But most of you, if I flip the coin 10 times, and you would probably feel pretty good about calling me a cheater, right? Now you could be wrong, and that's what you're pointing at. You could be wrong. That's what I'm trying to point out. The mistake is that it could be a fair coin, but you called me a cheater. Okay, so you made a mistake. Okay, so that's what we call a type 1 error, and we use the letter alpha. Okay, you called me a cheater when you shouldn't have. Okay, now let's talk about the other type of mistake that could be made. Let's say that, like Adam, you're being really strong here and saying, I don't care if it comes up 10 heads. I'm not going to call you a cheater because I could be wrong. And it was a two-sided coin. Okay? So you could say, I'm not going to, the alternative was true, you were cheating, but I did not reject the null. So I made a type 2 error. We're going to refer to that as beta. Okay? Now the question is, so there's 2 types of mistake. You could reject the null when you shouldn't. You could not reject the null when you should have. Those are the 2 mistakes you can make. Okay? Now, which is the better mistake to make? Okay? So let's say, for example, going back to the pharmaceutical company, I still have it over here. Okay? So the type 1 error in this case says we believe that P is greater than 0.02 when it is not. Okay? So the idea here is 2% of the kids have side effects. You think your new drug has more than 2%, okay? So you're probably not going to release this drug because you think it's unsafe. So that's a mistake. Maybe it really was just 2%, but you're being safe. So that's what we're going to refer to as our alpha. Which mistake would you rather make? Or the type 2 error, the beta in this case, says we believe that the P is less than or equal to 0.02 when P is greater than 0.02. So we think it's safe, but then we release it to the public and we find out that it's not safe. Would you rather make a type 1 error or would you rather make a type 2 error? Probably type 1, okay? The type 1 is the preferred error that we're going to make. It's the more conservative error. You'd rather not make money when you could have than to make money and then get sued. Okay? That's the safer error to make. Yes.
Cases where type 2 sake of it. There's lots of cases where it makes money.
There are a lot of people, yeah, there are a lot of companies that make technical errors all the time.
Look up Chevrolet installs.
Okay? All right, so does that make sense, Adam? Do you understand
Yes.
what I'm trying to get at?
But in my defense, and sorry for being difficult, but in my defense, if he flipped tails 10 times and the outcome was we need to convict him to death row, would you do that?
We do it all the time. Especially as he's black. It's true. It's true. We will have some problems about racial disparities in the death penalty. So, yeah. So we do it all the time. And we don't use good statistics like this when we're doing it either. Okay? So, quiz tomorrow is on type 1 and type 2 and null and alternative. See y'all tomorrow. Start doing math again tomorrow.
Yeah, well, wait.